True projects. In this video, we are going to explain about the project entitled as Exploring AI Techniques for Yoga Image Classification, a focus on machine learning and deep learning. So before getting into the video, let me give you the brief description about the title. This title refers to studying how artificial intelligence can be used to automatically identify different yoga poses from images. It highlights the use of both machine learning and deep learning methods to analyze and classify the pose effectively. Coming to the abstract describes a study that aims to classify yoga poses using artificial intelligence. It explains that yoga pose recognition is becoming increasingly important for applications like fitness guidance, health tracking, and virtual training. The study investigates two main AI approaches: machine learning, which needs manual extracted features, and deep learning, which automatically learn feature from images. By using a public available yoga dataset, the research compares how well these methods perform in terms of accuracy, reliability, and speed. The finding shows that deep learning, especially convolutional neural networks, works much better than traditional machine learning. This suggests that deep learning is more suitable for creating smart systems that can analyze and guide yoga practice effectively. Coming to the existing system for yoga pose classification generally rely on traditional machine learning methods. These methods depends heavily on manual feature extraction, where experts must design and select features such as body angles, edges, key points, or shape descriptors before the model can classify the pose. Because this system does not learn features directly from the images, their performance is often limited, especially when dealing with complex poses, variations in lighting, backgrounds, or human body shapes. Additionally, traditional models may struggle to accurately recognize pose in real world scenarios and typically require significant pre processing and domain knowledge. As a result, existing system often lacks the accuracy, robustness, and adaptability needed for modern fitness, health, and virtual training applications. Coming to the proposed system or base paper work. The proposed system uses advanced deep learning techniques to improve yoga pose classification. Instead of depending on manual design features, it uses convolutional neural networks and transfer learning models like VGG16, MobileNet, and ResNet to automatically learn important patterns directly from images. These pre-trained networks already understand general visual features, which helps the system achieve higher accuracy even with limited training data. To make the model more robust, data augmentation is applied so that the system can handle changes in lighting, backgrounds, angles, and orientation. The entire process is end-to-end, meaning the model takes raw images as input and predicts the poses without extra manual steps. Lightweight architectures also make the system suitable for real-time or mobile applications. Overall, the proposed system offers a more accurate, reliable, and scalable solution compared to traditional machine learning approaches. Coming to the data set, the yoga pose classification data set is taken from Kaggle, contains approximately 988 images categorized into 5 yoga poses like down dog, goddess, plank, tree, and warrior 2, making it suitable for supervised image classification tasks. These images were collected using the Bing Search API, resulting in a diverse collection that varies in background, lighting, angles, and subject appearance, which helps improve model generalization. Organized into 5 separate folders, each presenting a pose, the dataset is directly compatible with deep learning frameworks such as TensorFlow and PyTorch. Although relatively small, it provides a valuable benchmark for experimenting with pre-processing techniques, data augmentation, and transfer learning models. While it lacks key points or skeleton annotations and is therefore unsuitable for pose estimation. It remains an effective resource for developing proof of concept yoga pose classification systems and evaluating the performance of both machine learning and deep learning approaches. Coming to the novelty or extension or enhancement or improvement. As an extension to the core classification system, advanced deep learning models such as Exception, ResNet 50, and an ensemble model combining Exception and ResNet 50 were applied to enhance classification performance. These models are known for their strong feature extraction capabilities and deep architectural design, enabling them to learn highly discriminative patterns from yoga pose images. This ensemble model, which integrates the strengths of both Exception and ResNet 50, further improved robustness and reduces the chances of misclassification. During model evaluation, the extension models achieved an impressive 100% testing accuracy, demonstrating their effectiveness in accurately identifying yoga poses. Additionally, the YOLO family of models YOLO V5, YOLO V8, and YOLO V9 was incorporated to detect abnormalities or specific key regions in the images, providing not only classification but also localization for relevant pose features. And to improve transparency and interpretability of the deep learning models, explainable AI techniques were integrated into the system. Specifically, GradCam, which is known as gradient weighted class activation mapping, was used to generate visual heat maps that highlights the most important regions of an image influencing the model's decision. These heat maps helped user understand why a particular pose was classified in a certain way by showing which body parts or images areas the model focused on. This not only increases trust in the system but also helps in diagnosing potential misclassifications, validating model behavior, and ensuring it learns meaningful visual features rather than irrelevant background details. As an extension, a Flask-based user interface was created for predictions. To make the system accessible and user-friendly, a web-based interface was developed using the Flask framework. The Flask application allows users to upload yoga images through a simple UI, after which the model processes the image and returns the prediction pose class. For extended functionality, the interface integrates the ensemble model for classification and YOLO models for detection, offering a complete prediction pipeline. The system displays the predicted classes, confidence score, and any detected regions, making it practical for real-world use. This development approaches enables seamless interaction with the trained model and demonstrates how AI-powered yoga pose classification can be integrated into web applications for fitness, training, and educational purpose. Coming to the flow of the work, firstly, we need to import the packages. In this step, all the necessary Python libraries are imported to support data processing, visualization, model training, evaluation, and deployment. Next, dataset preparation. The yoga dataset is collected and organized into two formats. One for classification with images, label pairing, and one for YOLO detection with bounding boxes annotations. The dataset is then divided into training, validation, and testing sets to ensure proper model development and unbiased evaluation. Next, data visualization. The class distribution is visualized using a bar graph to understand dataset balance, and sample annotated images are displayed to verify that labels and bounding boxes are correct. Next, pre-processing. For classification models, images are resized, normalized, converted into NumPy arrays, and features are extracted using transfer learning models. And for YOLO models, the data.yaml files is created and images are linked with their corresponding YOLO boundary boxes, labels to prepare the detection data set. Next, model training. The classification branch trains multiple models including VGG16, CNN, Exception, ResNet 50, and an ensemble to learn the yoga pose. The YOLO branch trains several versions of YOLO like V5, V8, V9, V11 to detect yoga poses by identifying both the location and the type of the pose in an image. Next, we have evaluation. Classification models are evaluated using accuracy, precision, recall, F1 score, confusion matrix, and ROC curves, while YOLO models are evaluated using MAP, precision, and recall to determine the best performing detector. Next, interface pipeline. For a new input image, YOLO first detects the yoga pose and draws boundary boxes, and then classification ensemble confirms the final pose type and confidence score. And next, Flask web app. The Flask application allows to upload an image, process it using the trained YOLO and classification models, and return the results. The detected yoga pose, the predicted class, and the confidence score, and the image with the bounding boxes are drawn. The algorithms used in the project are: for classification, we used VGG16, CNN, Exception, ResNet, and Hybrid Ensemble. And for detection, we used YOLO models like V5, V8, V9, and V11. Coming to the requirements, we have hardware requirements and software requirements. Hardware requirements consist of operating systems, Windows only, processor i5 and above, RAM 8 GB and above, hard disk 25 GB and above. Software requirements consist of application framework is Anaconda, primary language is Python, front-end framework is Flask, backend is Jupyter Notebook, database is SQLite 3. Technologies which we use to build the front-end are HTML, CSS, JavaScript, and Bootstrap 4. To execute this project, first we need to open the code folder, which contains the project source code files. This folder is a complete package of your project's code base containing everything needed to develop, test, and deploy your application or model. Static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. Template folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represents different pages of the website. App.py file. This .py file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are the model files which contains algorithm information which will be loaded into the project code during the runtime. These are notebook.ipynb files. This is a Jupyter Notebook file which contains the combination of code, graphs, and outputs all in one place. It allows users to write and execute the code in individual cells, making it a popular choice for data science. Signup.db file. This file is a database file used to store user information. Coming to the execution of the project, firstly, you need to copy the path of the code folder from the address bar of the file explorer. Then open Anaconda prompt. Use the command cd followed by a space and then paste the copied path. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py in the Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address with the port number of 5000. Copy the local link provided by the framework and paste it into any web browser. I prefer Chrome. The home page of the project should now be displayed in the browser. This is a front end built using Flask framework. In this page, we have home button and sign up button. Now click on sign up button so that the logon HTML will be opened. Here, we need to give the details and create an account for user authentication like username, full name, mail ID, mobile number, and a strong password. Then click on sign up so that all the given details are stored in signup.db and then the login HTML will be opened where we need to access the application by username and password. Then click on sign in so that the prediction page has been displayed. In this, we have home button, graphs button, notebook button, and sign out button. So firstly, click on home button. In this, we need to upload the yoga pose images. We have classification and detection. Firstly, we need to click on AI classification so that the uploading for classification will be opened. Here, we need to choose the image from the code folder. As we are detecting the poses for AI classification, we need to open the test cases, and in this, we need to open classification. And from here, we need to give the input image. The image has been selected. Now click on classify the pose. The input image is pre-processed and the output will be displayed as downward facing dog pose. So the confidence level is of 100. The difficulty is for beginner. This is the original image and this is a heat map image by using GradCam. About this pose, the information is given here and the benefits of the pose has been displayed here and how to perform is being given here and the precaution to be taken is being here. Then click on upload another image. So for AI classification, here we need to upload an other image. So firstly we given from down dog. Now we'll take another image. The image has been selected. Click on classify pose so that the output is predicted as goddess pose. The confidence level is 100%. Difficulty is like intermediate. The original image is given here and the heat map image by using GradCam is given here. About the pose, it is a powerful standing pose that strengthens the legs and opens the hip. The benefits of the pose is given here. How to perform is given here and the precautions are given here. Then go back to home and YOLO detection. So for the YOLO detection, we need to upload the detection of YOLO images here. Choose the images. Again, we need to go to the code folder and open the test cases. Here we have detection folder. Open the folder and give any one of the image and upload. Now click on detect pose so that the input image is pre-processed and the output is detected as YOLO pose detection. So here is a given image. The detection results with bounding boxes has been given here. The name is goddess. Click on upload other image. For YOLO detection, upload another image and click on detect pose. The pose has been detected as plank with the help of bounding boxes. Then click on graphs. When you click on graphs, the class performance metrics for AI model evaluation and YOLO model evaluation will be shown here. So firstly, you have number of image count per class graph. This bar chart shows the number of images available in each class of the dataset. All classes contains roughly the same number of images from 196 to 199 each. This indicates a well-balanced dataset which helps prevent bias during training and supports stable, reliable model performance. And next we have confusion matrix and ROC curve graph. Confusion matrix graph. The confusion matrix visualizes how the hybrid ensemble model performs on each pose category. Each row shows the actual class, while each column shows the predicted class. The dark diagonal blocks confirm that all poses are classified correctly with no misclassification. This indicates perfect or near perfect performance where every test image is predicted as its true value. The ROC curve for hybrid ensemble. The ROC curve illustrates the model's ability to distinguish between different pose classes. Each colored line corresponds to one pose category and all lines hug the top left corner indicating perfect sensitivity and specificity. The AUC of all classes is 1.00%, confirming the hybrid ensemble flawless performance is differentiating the classes. And next we have accuracy graph. This bar chart compares the accuracy of several machine learning models used for pose classification. Each bar represents a different model. Example, VGG16 variants, CNNs, exception and ResNet, and hybrid ensemble models. All models achieve very high accuracy, close to or at 1.0%, indicating that each architecture performed extremely well on the dataset. The hybrid ensemble also performs nearly perfect, suggesting that combining model prediction improves or maintains strong accuracy. Next, we have F1 score graph. This graph shows the F1 score of each model, which is the harmonic mean of precision and recall. High F1 score across all models indicates a strong balance between precision and recall. The hybrid ensemble, exception, and Resonate 50 models lead slightly, confirming their robustness overall performance. Overall, every model demonstrates excellent classification capability with minimal discrepancy between them. Next, we have recall graph. This graph displays recall scores for the same set of models. Recall measures how many actual positive cases the model successfully identified. Similarly, to the precision chart, all models reach very high recall levels, suggesting they effectively detect the true positive samples. The hybrid ensemble and exception models again perform slightly better, but also models show strong consistency. Next, we have precision graph. This graph compares the precision of several machine learning models. Precision measures how many of the model's positive predictions were actually correct. All models shows very high precision, indicating they rarely produce false positive. The hybrid ensemble, exception, and Resonate 50 appear to be among the top performers, but overall the variations among models is small. Next, we have YOLO model evaluation graphs. Firstly, we have YOLO precision score graph. This graph displays precision values. YOLO V9 leads with the highest precision, closely followed by YOLO V5 and V8, which shows very similar results. YOLO V11 has noticeably low precision compared to others, though it remains at the responsible good level. Next, we have YOLO recall score graph. This graph illustrates recall scores for the same YOLO models. YOLO V5 and V9 achieves the highest recall, both close to 0.9%. YOLO V8 performs slightly lower but still strong, while YOLO V11 has the lowest recall among the models around 0.8. And next we have YOLO MAP score graph. This graph compares the mean average precision across 4 YOLO model versions. All models shows strong performance above 0.85, with YOLO V5, V8 and V9 performing nearly identically at the top. YOLO V11 shows a slightly lower MAP, though still high overall. Then click on sign out. So finally, this project demonstrates that both machine learning and deep learning techniques can effectively classify yoga poses. But deep learning, especially convolutional neural networks, provide significantly higher accuracy and better generalization. By leveraging image-based learning, the system can reliably recognize complex body postures, highlighting AI's potential to support fitness, training, and wellness application. Overall, the study shows that integrating advanced AI models can greatly enhance automated yoga pose classifications and pave the way for smarter health tech solutions. So this is all about your project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.